Hi everyone, my name is Pavitra B, Department of Chemistry. Today we are going to discuss a topic called periodic table. So this is the modern periodic table we are using nowadays, which is consisting of 18 groups and 7 periods. In these 18 groups, the color which are marked in white color are representing non-metals, and this is the first group which is representing in a blue color, which is nothing but alkali metals, and the second group elements are called alkaline earth metals or alkaline metals. Both alkali metals and alkaline metals will form S block. From third group to 12th group, we will be having a transition elements in this purple color, which is represented as a transition metals. In that colors, we have two green colors blocks, that is nothing but rare earth elements, that is lanthanides and actinides. We have a F block, we are calling it as a F block elements, which are nothing but lanthanide series and a actinide series. So the majorly present F block elements are radioactive in nature. Other than that, from group 13 to other, we have a P block elements. So these are called P block elements. The black color blocks represents the noble gases or the inert gases, which is having a complete electronic configuration filling by an electrons. And this yellow blocks represents the metalloids. Metalloids are nothing but having a properties, both metallic properties and non-metallic properties. And this red blocks indicates the halogens, fluorine, chlorine, bromine, iodine and astatine. These are the halogen groups. And this cement color blocks indicates the other metals having a different properties like semiconducting properties. And this is the explanation of modern periodic table. Before that, we will give an introduction for a periodic table. The periodic table is made up of rows of elements and columns. An element is identified by its chemical symbol by a capital letter, and sometimes there will be a both capital letter and a small letter indication. The number above the symbol is its atomic number, and the number below the symbol is its atomic weight. Atomic weight is nothing but total number of protons and neutrons. Atomic number is nothing but the total number of protons, or it may also equal to the number of electrons. Here the rows are called periods and the columns are called groups. We have 18 groups and 7 periods in the modern periodic table. This is the organizing of elements in the earliest times. Chemists used the properties of elements to sort them into groups. J.W. Dobryner grouped elements into traits. Traits are nothing but it is the set of 3 elements with the similar properties. For example, chlorine, bromine, iodine. These are the halogen groups. In the form of triads, they have arranged the elements. This is not applicable for all the elements because some elements are not forming a triad, or there will be not a 3 element set. Sometimes it will be more than 3 elements, or sometimes it is less than 3 elements. One element is differ in some properties from the other. So this method was ruled out. Next came the Mendeleev's periodic table. In 1869, a Russian chemist, and he is also a teacher, who published this table of elements. Mendeleev arranged the elements in the periodic table in order of increasing atomic mass. So he considered the atomic mass. Somehow it is also ruled out. It is not applicable for all the elements with a unique properties. So further, Henry Moseley in 1913, through his work with X-rays, he determined the actual nuclear charge, that is the atomic number. Then he think of the atomic number arrangement will be applicable for this periodic table. So he arranged the elements in the increasing atomic number. There is in the atom a fundamental quantity which increases by regular steps, as well as there will be a continuous increasing in the atomic number. He framed this around 1887 to 1915. So in the modern periodic table, elements are arranged in order of increasing atomic number. There will be some modifications made for this Moseley's or the periodic table given by Henry Moseley. So we have a periodic law, that is, when elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and also in chemical properties. So this is the periodic law given for a periodic table. The elements can be grouped into three broad classes based on their general properties. The three classes of elements are metals, non-metals and metalloids. You know, metalloids are nothing but having both properties of metals and non-metals with slight changes. Across a period, the properties of elements become less metallic and more non-metallic in properties. Next, we will discuss the families on the periodic table. Elements on the periodic table can be grouped into families based on their chemical properties. Each family has a specific name to differentiate it from the other families in the periodic table. Elements in each family react differently with other elements. Now we will see what are the families present in the periodic table one by one. First one is the alkali metals. So you can see in the periodic table, first group, that is lithium, sodium, potassium, rubidium, cesium and francium. Here hydrogen is not a member because it is a non-metal. So this is alkali metals whose one electron in the outer shell, which that is a valence shell. When we come to the external appearance, they are soft and silvery metals, very reactive especially with water, and they conduct electricity as they have a valence electron, one electron in the outer shell. They are the good conductors. Next one is the alkaline earth metals. They are mentioned in a green color. So these are having two electrons in the outer shell. They are white and malleable. Malleable is nothing but they can be drawn into thin sheets. Ductility is nothing but they can be drawn into thin wires. Reactive but less than alkali metals. They also conduct electricity. Next one is the transition metals, that is D block elements. They are the good conductors of heat and electricity, and they can be used in a jewelry purposes. The transition metals are able to put up to 32 electrons in the second last shell, that is the penultimate shell. They can bond with many elements in the variety of shapes. For example, coordination compounds. You have studied this D block elements in coordination compounds. Next one is the boron family. They have mentioned in the red color, 3 electrons in the outer shell. Most are metals. Boron is actually a metalloid in nature. Next one is the carbon family, that is group 4. There will be 4 electrons in the outer shell so that they can form 4 bonds with the other elements. Hence they are also called tetravalent in nature. Whereas boron family is called trivalent. They can form 3 bonds with other elements. Whereas the carbon family members, they can form 4 electrons with the other elements. Hence they are called tetravalent in nature. They contains metals, metalloids and also a non-metal, which is a carbon. Carbon is a non-metal. And next one is the nitrogen family. They have 5 electrons in the outer shell. which is a pentavalent in nature. Sometimes it forms 3 bond pairs and 1 lone pair electron. They can share electrons to form compounds. They also contains metals, metalloids and non-metals. And next one is the group 6, which is mentioned in a blue color, which is having a 6 electrons in the outer shell, which contains metals, metalloids and non-metals. They are also reactive in nature. Next one is the halogen group, that is group 7. They are having a 7 electrons in the outer shell, only 1 electron deficient to get a octet configuration, that is complete filling of electronic configuration, or the orbitals. They are deficient from 1, they are deficient by 1 electron. They are all non-metals in nature, very reactive, are often bonded with elements of first group. So when they come to bonded with the first group elements, they will get a octet configuration, and the first group elements, by losing 1 electron, they also can get into the octet configuration. We know octet configuration is the most stable configuration. So for example, NaCl, Na sodium gives 1 electron to form Na plus and comes to the octet configuration. Cl, chloride ion, will absorb 1 electron given by the sodium to form Cl minus and comes to the octet configuration. They form NaCl, which is a most stable salt present. Okay. Next one is the noble gases. They are exist as a gases itself, and they are non-metals in nature. They have 8 electrons in the outer shell, that is completely filled electronic configuration. Helium has only 2 electrons, that is an exception, but also it is a completion of electronic configuration like 2s2. So next, they are non-reactive with other elements, hence they are also called inert gases. Next one is the rare earth metals, that is nothing but our F block elements. Some are radioactive in nature. The rare earths are silver, silvery white or grey metals. They also conduct electricity. These are the families of periodic table, and this is the modern periodic table, in which this is the symbol. We are taking an example of carbon in order to explain each element. This is the one block. For example, this is the atomic weight and this is the atomic number. This is the element symbol. We are taking the symbol of carbon. In carbon, 6 is the atomic number, that is the number of protons present in the nucleus of a carbon, or it is also equal to the number of electrons. And this 12.011 is the atomic weight, that is the total number of protons and neutrons present in the element. So this is the symbol which represents the element. This is the modern periodic table, which consists of S block elements, P block elements, D block elements and F block elements. This is the explanation of periodic table.